In electrical systems, the standard color code for ungrounded conductors serves as a crucial visual aid for identifying different phases and voltage levels. For a 208 volts three-phase delta system without a high leg, the common color code is black, red, and blue. This arrangement helps electricians quickly differentiate between the three phases. In a 240 volts one-phase split-phase system, the standard colors are black and red. This simpler configuration reflects the two ungrounded conductors in this type of system. When dealing with a 240 volts three-phase delta system, the standard color code often includes black, red, and blue, with the blue conductor typically designated as the high leg. The use of blue for the high leg in 240 volts three-phase systems stems from its traditional role as the neutral conductor in 208 volts three-phase systems. This carryover aims to provide a degree of familiarity and consistency for electricians working with different voltage configurations. To further enhance the identification of the high leg conductor in 240 volts three-phase systems, some electricians employ additional color codes. One common practice is to apply orange or yellow above the blue conductor to clearly indicate it as the high leg. These bright colors serve as an extra visual cue, particularly in environments where multiple voltages and conductor colors are present. Another color that is sometimes used to indicate the high leg conductor is brown. When deciding on a color code for ungrounded conductors, several important factors should be considered. Firstly, it is essential to consult and adhere to local electrical codes, as these codes may have specific requirements for color coding. Secondly, maintaining consistency and clarity in the color code throughout the entire system is crucial to prevent confusion and ensure that conductors can be quickly identified. Thirdly, safety is paramount. Clearly identifying the high leg conductor is essential for preventing accidental contact with higher voltages. Employing appropriate color codes and warning labels is a vital safety measure. When working with electrical systems, the proper identification of conductors is essential for safety and efficient maintenance. The color coding system is designed to make this identification straightforward, but variations and additional indicators can sometimes add complexity. In a 208 volts three-phase system, the conductors are typically colored black, red, and blue. This standard arrangement allows electricians to easily distinguish between the three phases, ensuring that connections are made correctly. Moving to a 240 volts one-phase system, the standard colors are black and red. This simplified scheme is used because there are only two ungrounded conductors in a single-phase setup. The color difference helps to differentiate between the two lines, preventing errors during installation and repairs. However, the situation becomes slightly more complex when dealing with a 240 volts three-phase system, particularly when it involves a high leg delta configuration. In this case, the common practice is to use black, red, and blue, with the blue conductor designated as the high leg. The high leg, also known as the stinger leg or wild leg, has a higher voltage to ground compared to the other two phases. To avoid confusion and potential hazards, it is critical to clearly identify this conductor. The rationale behind using blue for the high leg stems from the common practice of using blue as the neutral conductor in 208 volts three-phase systems. By carrying over this color, electricians familiar with the 208 volt system can more easily recognize the high leg in a 240 volt system. However, relying solely on the blue color can sometimes be insufficient, especially in environments where multiple voltage systems are present. To provide an additional visual cue, many electricians choose to add orange or yellow tape or marking above the blue conductor, indicating that it is the high leg. This extra step can significantly reduce the risk of accidental contact with the higher voltage. Using orange or yellow as an additional indicator is particularly beneficial in areas where different voltage levels and conductor colors might be encountered. The bright colors stand out, making it easier to spot the high leg even in dimly lit or crowded electrical panels. In some regions, brown is used as the designated color for the high leg conductor. This is less common than using blue with an additional indicator, but it is still a valid approach as long as it is clearly defined and consistently applied throughout the system. When selecting a color code for ungrounded conductors, there are several critical considerations to keep in mind. Firstly, it is essential to consult and comply with local electrical codes. These codes often specify the acceptable color schemes and may vary from one jurisdiction to another. Ignoring local codes can lead to safety violations and costly rework. Secondly, consistency and clarity are paramount. The chosen color code should be applied uniformly throughout the entire electrical system. This ensures that anyone working on the system can quickly and accurately identify the different conductors, reducing the risk of errors and accidents. Thirdly, safety must always be the top priority. The highlight conductor carries a higher voltage to ground, making it particularly dangerous. Clear identification of this conductor is essential to prevent accidental contact and potential injury. In addition to color coding, warning labels should be used to further highlight the presence of the highlight. These labels should be placed prominently near the electrical panel and at any points where the highlight conductor is accessible. The labels should clearly state the voltage to ground of the highlight, as well as a warning to avoid contact. It's also crucial to educate electricians and other personnel who may be working on the system about the specific color codes and safety precautions in place. Regular training sessions can help to reinforce these concepts and ensure that everyone understands the risks associated with high-leg data systems. When working on any electrical system, it's important to follow established safety procedures such as wearing appropriate personal protective equipment, using properly insulated tools, and energizing circuits before working on them. These precautions can help to minimize the risk of electrical shock and other injuries. The use of color codes for electrical wires is not just a matter of convenience, it's a critical safety measure that helps to prevent accidents and ensure the proper functioning of electrical systems. By understanding the standard color codes and following local regulations, electricians and other personnel can work safely and efficiently, reducing the risk of errors and injuries. Always remember to double-check your work and verify the voltage of conductors before making any connections. A little extra caution can go a long way in preventing potentially dangerous situations. In summary, the correct identification of conductors in electrical systems, especially in 240 volts 3-phase delta systems with a high leg, is paramount for safety and proper functionality. Adhering to standard color codes, using additional indicators like orange or yellow, and consulting local electrical codes are all essential steps.